Good morning, everyone. Let me know if the videos are fine. Everything is good. Get started coding. Not quite a good morning for my city, to be honest. What the hell? Everyone. Oops. Oh yeah, so just to give you a little background. It was 40 missiles yesterday in the neighbor region to my city, and it's 14 missiles this morning, like 3 hours ago. Yeah, 3 hours ago. My city. A couple of them hit the buildings. I'll just show you, just to give you a little background, because, you know, this is where I live in. I actually drove past this house yesterday. It's just the usual residential building. All right. Yeah, missiles. They look like some stuff they can fire from 1,000 kilometers. And yeah. Hello, guys. All right. I think you pretty much can see it on the news. So let's get to business, I should say, right? So yeah, first of all, one of my the people I related to, actually, this is kind of my cousin who serves in the army now. He asked me for a little help. It's not really. I'm not gathering millions of dollars. I just need like some small amount of money, and probably the the money I would not gather with donation. I will just throw myself. So it's fine. Any kind of donations are appreciated, even like $2, $5, any kind of things. So you can get them with those two things, and I really appreciate any. It's not obligatory, obviously, but I really appreciate the help. So it's going to be in the description of the video if you're looking this in the record. All right. So today I wanted to decompose this effect, which I kind of announced the last time. Yeah, kind of have a Japanese stream today, right? So this effect, and because I know another way of doing it, and I was surprised that they didn't use the like the effect that I like the way that I thought they're gonna be using. So I decided to show you both ways. So it's kind of a challenge to me because we're gonna create two animations today, even though they're both kind of simple. So I hope I can manage that. Kind of pressing myself because one animation in 1 hour is too easy now. Too easy. Yeah, thank you guys. I'm good. It's just like I could see the impact place from my window. I mean, the smoke and the stuff, but I'm fine. It's like 3 kilometers from me, the direct line, so in the center of Kiev. I'm fine, but not everybody's fine. People died. Okay, so right, the stream. So let's create the folder. How do I call it? Let's call it race. Race. I'm gonna get my usual template and start all the things. Boom, boom, boom. Desktop. Race. Let's arrange the window. Get started coding. Also, I'm always curious, like, where you're from, guys, so just let me know where you're watching it from. Live. Always surprised. Alright, so let's do the things. I'm gonna install all this stuff and then open my usual template. Yeah, Nightingale 2. I actually did it. I also already decompiled it, but it's too complicated. I guess it's gonna be some other kind of format. It's not streaming. Maybe I'll create a record, maybe a course, like some, I don't know, $5 charity kind of thing, but still. So it's gotta be, I think, to share the Nightingale ways of doing the animation, I gotta make a recording because it's too much things to do it live. It's not gonna be fun to watch it live. Oh yeah, Kharkiv. Actually, you know, in Kiev we had 14 missiles, but I believe in Kharkiv they get this like every single day now, this amount of explosions. It's just that we had some time without missiles in Kiev, so we are back again. Right. Rainy morning in Ireland. Love that. Okay. Streaming, yeah. That's strange stuff. Please see the last message. All right. So first of all, surprisingly to me, oh, they're using the sound. So first of all, we actually still in the air raid alert in Kiev, but who cares nowadays? Okay. So actually, I was surprised that they used a lot of elements for this one. So if you go into the, I don't know, any debug tool for the webgl, you'll see lots of shaders being used because they use the separate thing for this like bright area on the planet. They use the planet obviously as a separate shape, and then they use the separate shape for the arrays and the shuttle and then the particles, and then okay, they're using a lot of things, but it looks beautiful, right? So first of all, surprisingly to me, they are actually using this kind of 3D model to implement the race. Surprisingly, because later on the stream you would see that I thought of the other way, which kind of looked easier to me. Maybe not uh, as flexible as this one, but still. So they're using this 3D model. So let's get this 3D model. I also downloaded two images. They're using the normal map and the diffusion, just the texture of the moon, diffuse map. Yeah, it's called diffuse. Diffuse is usually the name, like the visual or what's graphics, video graphical effects, 3D name for the just texture, just the default texture is the diffuse texture. Okay. So let's create the rays and the moon. Let's add them to the scene so we could see something. Let's see how this effect could be implementable. Yeah, there's also a bump map, but this is just a normal map, and there's also something else like alpha map, stuff like that. All right, so we have the GLTF loader, so let's import the assets. My thoughts are going like sideways. It's hard to concentrate, even though it's not my house that has been hit, but still. Okay, model called race chill beam, and then I also need the U map. Get this one, moon diffuse. I also installed Copilot. The other, like on the positive side of things, I installed. I'm trying Copilot of the by the GitHub, and it's pretty cool. I'll show you what you can do with the Copilot with a three.js. So it's gonna be normal, right? Both normal and diffuse, both JPEGs. Okay, we got them. Now I have to download the things. So this GLTF, race GLTF. This model. Let's console log this one. And this scene. Right, so we have the race on our scene, and also this is kind of an important thing. This is actually not the single mesh. These are actually 4 meshes, and they are named like race B, race A, outer, inner. So they actually change the rendering depending on the mesh. So they don't render this like a single object and simple as that. No, they're using shaders. You could see also that when we rotate this thing, the rays are getting to the viewer, like you are in the race, like a God rays effect or something like that, which is pretty cool. Okay, so first of all, I want to set my material to the race, because right now it's, I don't know, it's just yellow. So this model. Oh, guys, I hope you're good in Kharkiv. Hope you're not in Saltivka, right? This is the most dangerous place right now. You can actually see what Copilot is trying to help me out. Like this model traverse function child. Well, I think right now it's not really helpful, but still. Okay. So this is gonna be the mesh. Oh yeah. So now you could see how the Copilot is helping me. So I don't, because I always forget whether is mesh is a function or is a property of an object. So this way I could just hit the tab and get this code, even though I don't really need like this part, but still. So if this is mesh material equals this material. Right, so we are just seeing the view, But what is peculiar about this mesh is that we actually have an attribute there. So attribute free color. We could actually output this attribute, but we will need the variant to do that. Have the V color. Okay, something is wrong. Or there's not much any vertex variant, because I because I cut it from there. Okay. Now we have this, which is not quite what I thought I would see. Yeah, so we are implementing this effect, but we're gonna do it twice, different ways. Well, at least that's the plan. Hope I can manage. Still have 15 minutes to implement the first one. I mean, more like 25 minutes. My plan is 25 minutes for the first one and then 20 minutes for the second one. Should be good. Okay. So somehow it's black, which is kind of surprising. Delete all the things. Right, so we have the this thing. I also replaced the sphere buffer. I kind of want to create the planet, so we see this scene all together. And instead of this material, let's add something like new 3, and then map. It's gonna be, you could see how the Copilot is helping me actually. And then the normal map, right? It's just writing code before I even imagine it. You know, and the variables are right because I have the unormal and the umap. So not only it guessed that I'm gonna need the normal map value and the texture loader, but it also guessed the variable name. This is mind-blowing. All right, so I believe in 100 streams, roughness 0.5. I don't know, maybe if Copilot says so, why not? So right, so we have the mesh, but we wouldn't see anything because mesh standard material requires lights. And let's make it black. So we don't see anything. And then I'm gonna add lights. Let's add some lights. Lights. And now when I try to create this map with lights, you know, I would need to add some ambient light and directional light there. But you know what? Hey, yeah, Copilot just write these codes for me. I don't really need the ambient light, to be honest. I just need the directional light, but still. Hey, come on. Yes, now we have the planet. It's lighted from one side. Kind of cool. Maybe the other side. Yeah, kind of looks like a planet now. And then we also have two other meshes which are still black. And I wonder why they are black. Because probably I messed up something with an attribute. Oh yeah, I'm not really setting an attribute here. I mean, the varying to output it. Right, so now we see those meshes and, well, actually, I think I gotta make the planet smaller. Uh, yeah, so planet smaller, rays are big. So what's interesting about this mesh they created is that they are actually encoded, and this is a pretty common way if you look into the Bruno Simon streams on Twitch or even his course. He explains how you can encode in Blender some attributes, which is really handy when you try to then animate them in the shader. So they actually set the attribute for the color, which you could use to animate the mesh geometry, let's say, even though it's just color, but you could use this color to animate geometry. This is exactly what we are going to do now. All right. But just to be clear what exactly encoded in the color, let's output two things. So we color just the red channel, and the red channel is basically the gradient, like from the start of the race to the end of the race. Basically just gradient. Then the G, the green, and the green is I believe this is the edge attenuation. So on the edge you could just hide something. Not sure why. I believe also it's something about the center part of the ray, just so you can see it's bright in the middle, but then it gets dark on the edge, but then it's still bright in the beginning of the ray. So it's something to make the ray more beautiful, so it's like close from inside, something like that. Anyway, so for now let's just output that white. Say it's gonna be bright white. Okay, next what we're gonna do, we're gonna implement some shader animation to my mesh. And this is gonna be a little bit interesting because I was like, sometimes when you decompile the animations, you kind of predict what's gonna be the next step of the guys, but this time they actually use something like unfamiliar way of doing things to me. So I thought like that'd be kind of interesting to implement it. So the important thing to take a note here is that all those meshes, they are not how I should say, like their positions are not just encoded in the buffer geometry, because in three.js you just save in the attribute position coordinates of all the vertices of the geometry. But it's not just that for those meshes, because they all have quaternion and rotation. So not only they have some positions, but they have some rotation. And the important thing here is that all of those meshes, they are just pointing upward. So it's just the vector pointing upward, and then they take the rotation with this vector. Where is it? Like this or quaternion, they're both, it's the same. It's a representation of the same rotation, both quaternion and the rotation with the Euler. So it's very important that all of those rays are in fact pointing upward, and that's what we're going to use today. So to create this effect, we're going to use the same technique that is also used for the Fresnel shader. And I mean, this technique could be described just like a dot product. But anyway, I'm going to take a dot product. So let's start doing things. So first of all, I'm going to create a new position. So we're going to distort the mesh. So first of all, new position. Oh, Japanese occupied my stream. By the way, I'm not sure, but I think it can, because it worked in the JavaScript and it also helped me with the CSS. So I don't think it shouldn't be working with the shaders. Yeah, you could see it's working right now. I don't know, you could even take some time to think like what is this AI trying to tell me to do with this animation? So basically it's gonna make it oscillate. I don't know. Let's just go with the Copilot for a second. I mean, it's just some weird little oscillation. Anyway, I don't actually need this. So first of all, where do I go? First of all those meshes are starting at 0 point. So what I need to do, I need to find the origin position. The origin position. It's going to be just the three-dimensional representation of 0. But because all those meshes are rotated, to get the global, like the world coordinate, we have to multiply this with the model matrix. So we'll have to multiply this with the model matrix, which actually, yeah, what I need to do, but not new pos, but just 0.0. So this is just like basically 0.0, center of the screen. I mean, it's beginning of the array. More like beginning of the array than the center of the screen. Then the axis of the actual mesh is going to be model matrix, again multiplied, but this time, well, almost. Copilot almost guessed correctly because I need the y pointing upward. It's going to be this. This is kind of the where the actual array is pointing now, from the point 0, 0, 0. It's pointing there. So to get the final thing, I would need to. This is actually 4-dimensional, I believe, because I will get an error now. Yeah, because of these both have to be 4-dimensional things. Right. Okay. Yeah, that's true. With a decent code base, it's even better. But even with I'm just literally writing just one JavaScript file, and it will already help me to create those slides because it's been added hundreds of times in GitHub already. Okay, so we have those two. So what I actually want to do, I want to get the vector pointing, like where the exact mesh is pointing right now. And to get this vector, I think I will just normalize the difference between these two. So back direction gonna be normalized, and then I need to subtract these two vectors. That's gonna be axis minus in position, and because this is a 4-dimensional kind of thing, I'll need to take the XYZ here. It'll be 3-dimensional. So this is the direction where the array, well, allegedly the direction where the array is pointing. We're gonna find out that pretty soon. So next, angle time pi. Okay. So now I wanna get the variable which is gonna be responsible for the actual difference between the angle of the ray and the screen, the viewpoint, right? I also need the camera origin. So is actually, I think there's got to be a variable. It's camera position or something. three.js position, right? Yeah, well, at least someone is asking what is it in JLSL, so it's gotta exist. So I believe I don't actually need this. And then plot alignment gonna be equal to the dot product between the camera position and direction. Oh, it's already there. And then so this is some value which represents the angle between me and the rays. So what I could do next usually when the Fresnel shader is used and this value is, you just multiply it with something. Okay, let's stop talking, just do the debug. Debug, just to see, we don't have JavaScript, okay. And then vdebug. Now this value could be negative actually. You could see the more kind of race, yeah, because it's getting negative. So probably I could play a little bit with this value. 0 and then no, I think I should also power it. Yeah, place to. Yeah. So now they're getting dark when they are looking sideways, but they are bright when they are looking more to the camera, right? But I think I gotta take it to extreme. So they're really bright only when they almost directly look at the camera. And then they should be more bright. I mean, it's not about brightness actually. I'm just debugging the value. So I created some kind of variable which represents how close is the ray towards the viewer. So right now I use it for the color, but I don't actually need it for the color. What I want to do actually, I can multiply the whole new position, which is the vector. I can multiply it with the what? With actual alignment, but then it's gonna just scale completely. Ooh. You could see when it's not looking to me, it's just being scaled. And also, I think I should normalize it to 0. When I get back, it's actually kind of a weird animation. We are distorting the geometry. Right. So to normalize the things, we could actually multiply with something else. So this is where the color comes into the play. So we could mix and mix depending on the color. Some weird sounds on the streets. And we are still in the error rate alert, so that could be anything. Okay. So I want this value between 0 and 1, first of all. And I want it to scale with the V color R, which is bright in the beginning, so it scale less at the start of the ray and scale more at the end of the ray. And then here, let's just create a smooth step between the okay, we could just create alignment, I think, first. Something like this. Still too big somehow. I don't think I should multiply it here, actually. I should just multiply my new position with the value. Yeah. Yeah, you could see them like getting smaller when they are not looking at us and then getting bigger again. I think I should also like this so they don't go too low. Maybe even that. Maybe for 1. Just want them. Okay, it's just the color makes it weird. So now they're getting small when they are on the sides and getting quite big when they are looking at the scene. And they only getting big when they are okay. All right. So the next thing that I want to also scale them, like make them more narrow. So for this, I could do new pos xc and multiply it with Well, it's trying to help me already. I'm not sure if this is the right thing to do. I think it was also something with the mix. And then what's here? Same thing again. Try the same thing. What this thing is doing actually is quite interesting because it makes the array more narrow. Maybe try this 3. So you could see, I mean, it's way too bright right now. It's make it much more wider when it's closer to the screen. This is what actually happening here. So you could see the rays are kind of looking intersecting and then they're getting white. Okay, getting there. So in a sense, this is the animation, but I kind of want to make it still a bit more nicer. I think I might have missed some numbers. It should be 1, right? I mean, now it's crazy. Now it's getting crazy. That's not output view debug. Something is wrong here. I believe I messed up some numbers. So this has got to be 0, 0. This has got to be it. Direction is axis minus regional position. And all of that normalized. This. Seems right to me, but somehow at some point it started to be really weird. So let's make it small again. I believe something is wrong in here. So this is not working as I want this to work. For some reason. What is this? Is this value too small or what? I mean, this is the thing that they're using there, but something is wrong. Let me think. XYZ, but this is three-dimensional thing, right? I'm just multiplying this with the alignment. Maybe smaller. It's like doesn't go all the way. Still a pretty weird way, as my opinion, to create those rays, but still a little bit of the messed up geometry. So I have the alignment here. Debug the alignment. Where else could have that been? Yeah, so I believe I heard the explosion then during the stream because it was a weird sound. Actually, might have seen though. Right. Okay, okay. You're not mentioning the morning ones. Of course, because we had someone at 6 a.m. Okay, so what is wrong here? Like something, okay, let's remove this for a second. So this way we only have the rays like just looking casually. Then I want to scale those rays. So basically I'm multiplying this with some kind of mixed value and then alignment. So I think this alignment is getting just too big. So I think better just 8 and then alignment. Yeah, I think this way they are staying kind of normal, and then yeah, get in there. So once we are like the rays are looking at me, they are getting bigger. I mean, you could of course make it 20, maybe times is gonna be enough. I kind of wanna hide them earlier than that. Okay, so this way we fixed this one. So I think this one should work as well. Yeah, you can see it's much nicer because it changes the angle. Because depending on the V color R, we're actually scaling. And we are able to get away with that because we know that all those rays are just pointing upwards. And this position, it's a like a local position. I forgot how they call it, like the local system of coordinates of the mesh. And the local system, it's just pointing upward. So when I rotate the X and Z, I mean not rotate, but multiply X and Z with something dependent on the V color R, which is just the gradient, we basically just change the angle like this. And it looks much nicer, right? So when you rotate, it's like you're getting into that ray. Beautiful. Okay, and then the last touch, which is also kind of surprising. I think we're getting like even too much of it behind. It's like the ray behind is too big now, but still. So the last bit is actually not, it wasn't obvious. I've never used it, to be honest. This is the first time I'm going to be using it in the three.js. So they used the blending and not the additive or any other, but custom blending. And they used the what I call blending equation. Hey, please help me, Copilot. But not adds, but max equation. So with this, I also need to set transparent true. I also need probably to set transparency. I mean, it's some weird thing, but also kind of fun. But I believe we are multiplying too much in here, so oops. So this alignment is gotta be smaller when it looks. So maybe I should just take the minimum or something in here. Or also a smooth step should be taken. It's too small. So they don't really get out of hand completely. Yeah, kind of like this. So we still be able to see the rays even behind, but the ones that you're going through are going to be cool. And you could see with the max equation, we were able to see the planet as well right now. So we are able to see the planet. I mean, if we make the planet a little bit bigger now, so it overlaps the rays, you could get this. And also, I think, remember if it makes any difference. It's kind of cool. But the other thing about this, you could see the like slight key thing in here, which is fixable with the with what? Because they had a couple of meshes and they actually rendering them in a different way. So not all of those meshes has the same material. They actually rendering them like one mesh is for the outer side of the array and another mesh for the inside side of the array. So they actually adding this part in another mesh, in another layer, so that you don't have this like black thing here, so you still have the array in here. And I think they also used some funky lighting, so let's just add the correct lighting and see how it looks and finish with the first one. So I think it was, I don't think I have it written. It's not 0 actually, but thanks for that, Copilot. So this is the color. Yeah, it's kind of a yellowish, light yellow. And then they used some weird, probably just multiplied this with this, right? Yeah, you're kind of getting this feel now. So when you're inside the planet, you just move the camera a little closer. So yeah, now it's small, and then it goes here, and it goes full in the rays. Then they also, of course, they have a separate mesh for this hole. So inside here, they have a separate thing in there, and also have, I think they implemented as another sphere inside the moon. And yeah, maybe let's look it up. I'll give myself 3 more minutes for this effect, and then let's move to the cool part. Moon Alpha, yeah, so they have the Moon Alpha. Let's try to implement it in 3 minutes. I don't succeed. So be it. And then do alpha, right? Am I doing it right? Do I see the other side of the planet now? Oh. Everything okay here? Mm, why is alpha map not working? Maybe I should set something like alpha true as well. Just maybe transparent true. Yes, I think we have those holes now. This is the hole. And then what I could do, the geometry. Let's say a little bit smaller than the previous one. I'm gonna put another sphere inside there. Yes, 3 small, and then new 3. Then where is my bright mesh? Mesh basic material. Not. Yeah, like this. So we could see the another mesh from the holes. And then let's bring back the rays. I mean, we still have to rotate them somehow, and I don't really know the correct rotation for that. So it's you gotta look up the the angle you should move them. But you got the idea, right? So if you just rotate this thing, the shape of them is similar. So they created everything in Blender along with the alpha map and these rays, and then just exported all the stuff and created this wonderful like rays kind of animation. Right, the rotation. So close, so close. It seems like it's flipped or something, but how would you flip? Okay, let's just try. I still have 1 minute to go. This this model. No. No. Again, no. This time. I mean, if it's one of the obvious angles, maybe I try to guess it. But no, maybe it's minus something. Ah, whatever. Okay, you got the idea. You got the idea. All right. Let's move on. Let's move on. So this is how they created the animation. Of course, there's much more. They have all the layers of the shaders, and they render this one with 4 different like shaders, way more complicated, but you got the idea. It's a mesh. We get the attribute, and then we distort the mesh depending on how close it is to the viewer, and then you get this, like you get this nice. It feels good actually, like when the rays get in narrow. I like this spot. And this is actually what we have here. Yeah, twice rendering. That's why they used second time rendering. And because of all those like edges, you get this kind of ray feeling, but it's just the geometry. Here, because of the one rendering I don't have them. Anyway, let's close everything and let's get a second take. What's that? Let's create another effect. So raise alternative. So just 48 minutes into the stream. I still have like 15 minutes of this one. Let's move fast. Move fast. And just to remind you, I'm gathering donation for my friend who serves in the Air Defense Forces of Ukraine. And if you could help with any donation, like maybe $3, that's fine. Anything counts. It's actually more of those small donations that make the impact. Right. Race alternative, I'm gonna call it. So you watch one stream, you get 2 techniques, and then get to business. Good to see you all, guys. I don't know if I could make it with position copy, like which position to copy where. So it's got to be some rotation, and they both have to have the same rotation. So and then race alternative again. It's like a mini stream. In a stream. Okay, have this, I have this. So first of all, I want to create a sphere, obviously. I want to create a sphere. Well, this second animation is going to be about Shvaino Karas. You know what I mean. This, instead of plain geometry, I'm going to create plain buffer geometry. Right? Not the plane, but sphere buffer. Set 30. Have the sphere. Let's make it a black background. So the second animation is done strictly in the fragment shader. I mean, in 2 fragment shaders, but still. What next? Next, I want to put some kind of texture in here. So I have this texture, which is a Ukrainian national meme. And let's put it in here. JPEG. From not the right guess this time for the Copilot. From map JPEG. And then I could put this map, probably just put it into shader, right? Where's my shader? Load SW, and then I have my view map inside my fragment shader. And then here, right, there we go. We have something. Not quite what I wanted to do it like this. F3 1 minus CR. Okay, it is actually helpful with the copilot, but this time it's black and white, so I could do this. Yeah, I just wanted to make it black and white. And then now, for the sake of having a lot of Schweinokaras, says Schweinokarasis. What is the multiple of Schweinokaras? I'm gonna have this. Let's move camera a little closer, or maybe make sphere a little bigger. Whatever. All right. So now we have the sphere of like the globe of Schweinokarasses. Karasius, Schweinokaras. Okay. What mathematical knowledge is needed to learn shader? No. My most favorite answer to this question is that shaders are actually a way to learn mathematics. It's not something you should prepare math before learning. Shaders and JavaScript and webgl is the best way to learn math. This is it. Well, of course, if you know some math, it will help you to be more proficient, but then to learn math, of course, you could read the books, but the most efficient way is to just try things out and see what is a sine, what is a fract, what does a fract mean? Well, obviously, it means repeating the texture this time. Like billions of Schweinokar. Okay, as many as I want. Kind of like this part as well. If you rotate the sphere, it's going to be pretty cool. Let's rotate it slightly. So it was this. Where is it? Hmm. Okay, so created a really nice animation, and then, but yeah, Nupi88 is correct on that too. If you learn trigonometry, like what is a sine and cosine, but then again, I believe that the best way to, like, how would you learn math in 2022? Reading books sounds boring, maybe watching videos, but still in the end, it's just when you try to implement the sine and cosine, try to like, use the sine and cosine, that's where you make it your knowledge. All right, next. So how do we go about this animation? Well, first of all, I need to render this one to texture. And for this, I'm going to create, initiate post-processing here. I wonder if Copilot will help me to fill this one. Probably not. But anyway, so I'm going to create the base texture, which I'm going to be using as the... Oh, thanks for... No, it's not what I wanted to do, actually. GL, right. Forget. Yeah, this width, this height. And then... yeah, I think it's linear, and then the same for the Mac filter. Not sure it really matters in this. And the most important one is it's gotta be RGBA. Yeah. So we got the texture. Next thing, composer. Actually, it actually tries to write code for me. Let's create another material. For this one, I'm gonna use fragment Post. Let's duplicate this one. Oh. Fragment post, and let's just output something stupid here. Something like this. So it's going to be just red. So if we render it to the screen, we gotta get something red. So then this scene I'm going to be rendering to the texture, and then I'm going to output my post-processing right on the screen. This I'm gonna need the camera. Well, aspect. Do I need the aspect in this case? Probably, I don't know. I think I don't, because I want to render this full screen. Doesn't matter. Yeah, so it's going to be camera post for the post-processing. Going to be orthographic because I want it just full screen. And material ortho is going to be, well, kind of the same thing. Same but different. And here I'm going to have the view map as well, which is going to be empty. Beginning. I have the solution, I don't need the time, I don't need, what else could I need here? Well, probably that's it. So I'm just gonna need the map and then the fragment post, because this is the post processing. Then I gotta create the mesh to use it. Also, let's just, to be safe, let's make a double side, because you don't know which side you're looking at, the plane buffer geometry, so gotta be safe with that one. And then, well, let's create the mesh. And, well, kind of, yeah, but it's just one by one because the orthographic camera is going to be square. Gotta go one by one, and then right. So now if we render this scene, you probably should see something red. I did everything right. This scene post, camera post. Yeah, it's red. It's working. It's working. Then renderer, set render target. Yes, this base texture. Thanks. And then should I say thanks to AI? The polite way of thanking my robot helping me. So first of all, I'm gonna render my original scene with the swine fish, big fish, flying around, and then I'm gonna use this texture and output it in here where I output in the red one. How do you go about this? So we render the texture, then I have to set the texture for this material, orthographic material, uniform. Well, yeah, thanks, Copilot. You see, just throw code for me. So now UMap inside my fragment ortho, fragment post is this one. And then this one is I'm outputting to screen. So let's try to use this texture here. So if everything is right, I should just see the same scene, right? It's kind of right because I don't need the frag here. But it's still fun, right? So you could like zoom even in the post processing. So we have double fract, double repeat thing happening here. So all right, we see the same thing, but it's already the post processing. This means I could play with this texture now. And this is what I'm gonna do. So what I want to do, I want the rays of light coming from the big fish. Coming from the big fish. Yeah. That's what we do when they hit us with the missiles. We're making the big fish glow in the dark. Scary big fish. Alrighty. So now the most important part, the actual shader. Right, so there's a common way of doing this. First of all, I wanna, come on, man. Will this just hide him? Okay, a lot. Fuck Tinder, we are cheaper and fast. Cheaper and faster than Tinder. What do they mean by faster, though? Curious. Okay. Cheaper and faster than Naked HD. Naked HD. Okay. I want rays coming from this wine caress. Okay. Where do we start here? So first of all, I want a vector pointing from the center of the screen. For this, I'm gonna create like two direction. Should I say to center equals the center of the UVs are 0.5 minus UV. This vector is going to be pointing, actually output it. Yeah, so it's in the center, because if I just leave the UVs, we're going to see the UVs. Now it's a UVs normalized. So it's vector pointing always from the center to some other place. Next thing, I want to repeat my texture a couple of times, because like when I actually, let's remove this, have the texture. But what happens if I just add here something like, you could see it zooming. Like the bigger I make it, the bigger I zoom it. But what's gonna happen if I zoom it really slightly, like a little bit of the zoom, like 0.1, and then I add those two textures. So let's say C plus. See what is happening. It's already looking pretty cool, right? I mean, this effect on itself is kind of cool, but we achieved it just with the fragment shader, but it looks 3D. It doesn't look like something you could do with the fragment shader, actually. So what we're gonna do, we're gonna take this to extreme. Now I wanna float. I actually want float, I don't know. Let's make it 40. And then, what do we call? So we're gonna initiate the color. All the zeros, so it's just dark, and then I'm gonna add something, and then I'm gonna output the color. So now it's gonna be black or white. Or do I have a JavaScript first there? No, great. Okay, so I wanna add those things together now. Go about this. So I need some value like float. Lerp is just gonna be I divided by 40. So it's between 0 and 1 something. Then I want my color. I wanna add something to my color. So let's just sample. Going to be, I wonder if I can use this name sample. Let's call it my sample. No, I don't think I need int, because I'm dividing it, because it's gotta be, it shouldn't be int, it should be a float. So my sample is gonna be the texture sample. This was all for the debug. And then here into center, I'm gonna add like this lerp thing between 0 and 1. Multiply it with what? I don't know. Something small probably. I need 0. So we are taking the texture 40 times right now. And the color is, why is it black though? I mean white. Why is it white? Of course it's white, probably because we added too many things together. So because we are adding all of the text, I'm not doing anything actually. Yeah, yeah, made a couple of mistakes. Still gonna be white. Let's try this one. Yeah, probably it was with the alpha, yeah. But we still need to play with the alpha here. So color, I'm gonna add my sample to color, but I'm gonna add so first I'm gonna probably multiply my sample RGB with alpha of my sample. Then I'm gonna add color my sample. And this way I gotta achieve something. Yeah. So we are just like putting the texture on top of the other texture and getting this repeatable thing. You know, I could get it into the extreme. I mean, probably the strength should be also bigger. So if I go this, and the strength is something here, just getting extremely kind of crazy in here. I also see the behind of the texture. I wonder why. Maybe I should just create another sphere there. It's gonna be black. Okay, let's move it back a little bit. This, maybe like this, a little bit further. Something of this sort. Nice. Well, I don't know pure WebGL. I mean, I write shaders, but I don't write pure JavaScript WebGL API because it's a lot of writing in there. So what we could do here, first of all, I need to, I've lost the original texture. I only see this texture. The original texture is going to be here. So let's put original be equal just the default texture. Let's just output it for a second to see it. Yeah, this one, but I kind of lost it in all of those rays. And then because I'm adding too many rays, I'm actually yeah, I need to normalize that value. So inside here, total plus 1, I guess. So in the end, I could just divide. But the thing is, right now, all of those copies have the same weight. And what I want to do, I want to have them the different weight. And for this, I'm going to calculate this weight. I'm going to do it here. It's going to be weight. It's not going to be 1 anymore. This one going to be multiplied by weight again. And the weight I'm going to calculate like this. So the weight could be just, I mean, it could be just 1, right? For the starters. And is run, weight and declare identifier. So it doesn't change anything. But then I could make this weight to use some kind of simple easing function. Like for example, this could be the sine function between lerp multiplied by pi. And what I'm doing here essentially is this. This is why it's handy to know the trigonometry. It's multiplied pi. Can you do that? Anyhow. So if you multiply sine with the pi, I mean the argument of the sine with the pi, you get this nice function which goes to 1 and then again back to 0. This is what I want to do. So weight is going to be the sine of this lerp. Save it, and you could see already a different kind of effect. It's like blur because this means that the weight of the copies are different in the beginning and in the end. And then what I want to do here as well, color RGB divide with the total. Yeah, and you get this kind of thing. I mean, maybe I could write it with 4 or something to make it bright a little bit. But it's not too bright somehow. Maybe I just don't have enough copies. Anyway, you can control this thing. But we lost the original texture, so let's bring back the original texture. The easiest way to bring it back, I think, is to use the screen blending. So GLSL screen blend. Oh, this is already screen blending. Right, so the screen blending looks like this. So because I have the original sample here, I could calculate the final color in here. So instead of using the color, let's create the final color, which is gonna be this function, right? 1 minus, so it's gonna be 1 minus color multiplied with regional. Could it work? Could it just work for, for a change? Just work right away? Yes, it could. Okay. So now we see this wonderful effect. And it's already kind of similar, right? So we have those rays and they are pointing. There's one small touch left to do. JLSL random. Create a random. Random noise. I just need the basic random, like this kind of thing. So this takes two-dimensional thing and returns me float. Two-dimensional thing it takes, right? So in here, because this one is kind of an integer, and the random is going to be between 0 and 1, I'm going to add need two-dimensional thing, right? So like this. Accelerator random match number loaded function. Yeah, probably I need to do it in a way. Yeah, because when we add random, it should become more random, but somehow not yet very random for me. Maybe I could just want to randomize a little bit the sampling so we don't see the. Maybe I already randomize it. No, probably not. Is it really a random roll? Does it output something random? It's not, because why? Should return me float. What's running here? 1, 2, 3 open, 2 closed. Okay, it's not really random or what? Orthographic camera, because it's the easiest way for post-processing for another scene, because we're not rendering 3D scene now. So what's wrong with my random? Random. 1.0. I mean, maybe it's working, it's just that this is my random. Yeah, I guess so, because I need to put some different values here, right? For each sample. So it's gotta be working with the with UVs probably, or GL like screen position. So I gotta put something changing here. Yeah, but time will make it move, and I wanna make it still. I wanna leave it still, because with time it's gonna be like a noise. I don't know. Maybe UV should be just fine here. I mean, let's Yeah, with VUV it's kind of this noise, but we probably will be seeing this noise. So it's gonna be more complicated. No, it's fine. It's just that the arguments, the developer is not good. The developer is bad, not the function. Okay, so just the last bit, just more nice, beautiful with the noise. So yeah, I think it's gonna be working this way. I mean, yeah. So right now you don't really see the copies of the objects anymore, because we can make 4 of them. It's going to be just the slide effect, you know, just a little bit of the effect, and you could see a bit of a noisy. So I think you should apply the GL screen size, not the VUV, but the what's that variable, guys? Maybe you remember fragment shader GL screen. Point. It's not point coord. It's just the screen and shadow screen coordinates. Frag coord. Yeah, it's that one. And then what else? What else? What else? Sprint back 40. Yeah, so here we go. I think this is it. Gotta play a little bit more with the noise function. I think it's gotta be tied to something else. But anyways, it looks kind of good now. So we don't have those rings anymore, because once I remove it, let me remind you, when I have, well, if you look closer, you could see the copies. But this way you can't see them. So it's the same effect, but different, right? Also pretty cool. Also this kind of raise effect, but now implemented with the fragment shader completely. This kind of feel, has this feel, and maybe if I move a little closer and I make it a little stronger, this, you could be inside those rays. You could see the big fish in all its glory, right? Maybe like not the big of a random. But actually pretty weird effects in here, right? Different ones. Now I have to go full random, otherwise you see the edges. Pretty cool, right? Maybe I shouldn't even divide it. It's gonna be just, but it's, I mean, it's pretty cool. It's a lot of cool effects all together. So I'm gonna remind you that I'm gathering donations. If you're grateful for what I'm doing, just send some money, not to me. I'm gonna gather and I'm gonna buy personally all the stuff that the guys asked me to buy. And yeah, it's not weapons. It's pretty cool. I mean, I like it. I like how it looks from this perspective, right? What you could do as well is like different. There's a little bonus. I need a square texture with a different colored circles, because I believe it looks really cool with the different colors. So let's just look at, where are the circles when I need them? Okay, let's take this one. It's not that important which texture to take actually, but do I actually need to make it square? Don't. I just need to make it black. Yeah, that's what I need. Right, don't really care about the artifacts. Let's make it square though. Still, let's make it square. Image size. This is the one last bonus bit, promise. We're gonna finish. It's not image, it's a canvas size. Trace alternative. Let's get them. Let's get them. Even though I love Schweinekarась, just for the last bit, I'm gonna replace it with circles just to see how it looks like. So instead of using the S, comment that out. I'm gonna use circles. Is it all that broken now? Let's make it to 2, 2. Then put the correct texture. Yeah, it's already wild. But let's go to the fragment shader and let's switch it to 1. Let's just output the bar here. And it's, yeah, it's pretty wild, right? But it's, again, it's pretty cool. It's like a volumetric lighting or something. And again, I don't need, the strength is too big now. Strength is too big with Schweinekarась. Force, yeah. Yeah, so this way you get kind of a volumetric lighting, right? It's pretty awesome, I should say. And then make it 20 so it's more smooth. Too bright, and this is where the normalization comes. And this way it looks really, really cool. Then I believe these should be a little smaller. I mean, it's pretty cool, isn't it? So I guess this is it. I believe I should make all the Schweinekarась of a different colors with this effect for the demo in Twitter. So this is it. Oh, glad you catched me live. I catched you live too. Haha. I mean, we both catched each other live. Yeah, it wasn't obvious why we need the normalization part for the black and white, but in the end we still need it. I mean, here, not 4, it's total. It's gonna be much more natural and smooth this way. But yeah, it's not about, I mean, it's creativeness is not about smoothness. It's about experimenting and getting crazy output, and this is pretty wild, right? What we got with this Schweinekarась and all the other stuff. Pretty cool. So I hope you liked what we did today, because I liked it. It's been a long stream, one of the longest one, but it's 2 effects, right? And it's pretty cool. Thank you guys, everybody. All the support appreciated. Just watching and supporting with the words also appreciated. Thank you for doing that. This streaming really keeps me kind of alive. Actually, I didn't have any energy to stream today, but because my friend asked me to help him and I realized I don't have enough money, and I realized maybe I should stream for a good cause, like maybe at least something good would come out of this, and then I got the energy somehow. So this is where you got it. So once you hear the missiles hitting our city, the thing we do usually is not like hating, is not emotional. You just donate money to the funds that buy stuff to prevent this. This is basically the Ukrainian life now. Or you just go into the army and fight them. 2 ways. Hello, well, lots of love to Australia too. What the time is in Australia right now? It's like midnight. Hey guys, thank you all for supporting me. Links for the donations in the bottom of the screen or description of the video. And I'm gonna probably see you in a week. If I'm gonna be live, just kidding. I hope I will be. But if I will have something to stream about. So see you in the next one, guys. Have a good weekend. Say something good to the people you love. Do something good. See ya. Slava Ukraini. Yeah. Nice t-shirt, by the way. Link in the description.